Dear student, Assalamu alaikum and welcome to e-learning Al Noor International School, Grade 10 Chemistry course. I'm your chemistry teacher Fraz Anjum. Today we will discuss chapter number 12, stoichiometry, and lesson number 3, limiting reagent and percent yield. For this lesson, you should open textbook page number 400 till we will discuss 408. So please open your textbook page number 400. The resources you need it: textbook, notebook, calculator, periodic table, pen and pencil, etc. Today's lesson objectives are: explain how the amount of product in a reaction is affected by an insufficient quantity of any of the reactant, and explain what the percentage yield of a reaction measure. Okay students, let's start our main topic, limiting and excess reagent, also called limiting and excess reactant. So reagent or reactant, you can use both. Okay, so I'm using normally limiting reactant. So before I start this, we have to know the answer of this question: how is the amount of product in a reaction affected by an insufficient quantity of any of the reactant? Answer is, in a chemical reaction, an insufficient quantity of any of the reactant will limit the amount of product that forms. For this explanation, I'm just giving you one example first. Like you are working or you are owner of the factory in car assembly or car assembling factory. So you have two car bodies and 20 tires. So car bodies already you fitted the engine, everything. Now only tire going to fix it, left only. Okay, so you start fixing the car with the tires and you use 4 tires in one car and then other 4 tires in second car. So both car is ready to move. Now after the finishing this means car body is gone, finish. You don't have any car body to fix the tire, but you have still in the stock the 12 tires remaining. Okay, so means you should or you have to stop the production, and this is not good for the factory to stop the production. You must need the car bodies to keep it going, move to the product or keep producing the product. So in this lesson we will discuss all these things. Another general example I'm just giving you here. You can see that water, Nescafe, a cup, and this cup showing I love chemistry, and you have to love chemistry to understand the chemistry. So let's start now. 200 milliliter water. You need 1 pouch of Nescafe to prepare a cup of coffee. Now this is your chemical equation. You can see that Nescafe, 200 ml water give you 1 cup of coffee. Remember this. Now how is the amount of product in a reaction affected by an insufficient quantity of any of the reactant? Remember last question. Okay, here I'm just going to give you the idea that in this bottle how much water is there? 9 liter, and you have suppose 4 pieces of Nescafe pouches, and you have 6 empty cup or mug. Now let's start. These are your reactants, means before preparing the coffee, you have this thing. So let's start. You took a 1 cup first, put 200 ml of water, then 1 piece of Nescafe, then prepare 1 cup. Remember in the previous slide I discussed this, that 200 ml water, 1 Nescafe give you 1 cup. So 1 cup gone. Now second cup, you took the second cup from here, you took 1 Nescafe here, 200 ml water more, then second cup prepare. After that 1 more cup, then 200 ml of hot water, and then 1 more Nescafe. Third cup prepare. Then fourth cup you took, put Nescafe, and then 250 ml of water. After you finishing this fourth cup, you observe here you left here 2 cups and here a plenty of water still remaining, but you don't have Nescafe. So my question is, can you prepare the coffee? Correct. No, because we don't have the coffee. So how you can going to prepare the coffee then if you don't have coffee or you don't have the pouches? So means this coffee pouches run out. Okay, means finished, and production going to stop. And this is the indication, and if you understood this example, you understood limiting and excess reactant. Now among these 3 reactant, which one used up first? Good, Nescafe. So the reactant during the reaction who used up first, who run out first, who finish first, this called limiting reagent or limiting reactant. Again, the reactant among the 3 or 4, anyone who used up first, who finished first during the chemical reaction, this reaction called limiting reactant. And who left, this called excess reagent. So here who's the limiting reagent? Nescafe, because it finished first, who used up first. And which one is the excess? Here is water. Okay, water is excess, as well as you can say cup as well, because you have still remaining 2 cup. Okay, so water and cup is still excess. So I hope you understand this equation. Now let's start with the real problems. A balanced chemical equation is a chemist's recipe. Okay, if you have the balanced chemical equation, you have everything. That is, here is, see this, here it shows that N2 plus 3H2 give you 2NH3. Okay, this is balanced chemical equation, and by using this balanced chemical equation, you know that 1 molecules of nitrogen and 3 molecules of hydrogen combine together to produce 2 molecules of ammonia, or you can say 1 mole of nitrogen add up with the 3 moles of hydrogen and give you 2 moles of ammonia. Now question is, what would happen if 2 moles of nitrogen reacted with the 3 moles of hydrogen? Above one, check here. So before reaction, okay, you have 2 moles of nitrogen. So 1 mole means 2 nitrogen. Okay, so 1 moles of N2, another moles of N2, so 2 moles N2. Okay, remember this is atom, 1 and 2 atoms, and 2 atom of nitrogen give you 1 mole of N2 nitrogen gas. Okay, so diatomic here, so that's why it's called 1 mole. 1 mole of nitrogen and 1 mole of nitrogen. So overall 2 moles of or 2 molecules of nitrogen, and initially you have 3 molecules of hydrogen as well before reaction. Remember, before reaction. So how much ammonia you get? Nothing, because before reaction is nothing happened. You don't mix that nitrogen and hydrogen, you don't get anything. Okay, then after the reaction, what going to be happen? When you mix together after the reaction, what happened? That one molecule remaining still in the nitrogen side, and all 3 molecules of hydrogen used up to produce 2 molecules of ammonia. Why? Because we know that in the chemical equation, by the chemical equation we know that nitrogen, how many moles nitrogen we needed? 1. How many molecules of hydrogen we needed? 3. To get how many molecules of ammonia? 2. So by taking the 2 molecules of ammonia, we need 3 molecules of hydrogen, and we need 1 molecules of nitrogen. So remember here, 3 molecules of hydrogen. So before reaction, how many molecules of hydrogen we have? 1, 2, 3. So all 3 we can use it. And we have before reaction how many nitrogen molecules? 2. But we need only 1. So these 3 molecules with this molecules of nitrogen get 2 molecules of ammonia, because 1 nitrogen, 3 hydrogen, 1 nitrogen and 3 hydrogen give you 2 molecules of ammonia. So how many hydrogen left? Nothing. Means hydrogen used up. Hydrogen all finished. Hydrogen, the reactant hydrogen gone in after the chemical reaction. But you can observe here still 1 molecules nitrogen gas left, or 1 molecules of nitrogen left or remaining. This remaining nitrogen called excess, because we need only 1. This is my excess one, means extra. Okay, so who is the limiting reactant or reagent here? Hydrogen, because hydrogen used up all 3 molecules. Okay, so hydrogen used up all 3 molecules. So who is excess here? Nitrogen, because after the reaction it used only 1 molecule, and 1 molecule of nitrogen is still remaining. So because of still remaining after the reaction, that's why it's called excess reactant. I hope you understood. Now the same reaction, let's start explain like this. In this reaction only the hydrogen is completely used up, you can see here. That's why it's called limiting reagent, or the reactant that determines the amount of product that can be formed by the reaction. And this one amount of product depend on this, because it's used up. And how many product can be formed? Who is the limiting? So remember, limiting reactant always, okay, the product depend on the limiting reactant. Means if the limiting reactant finish, means product going to be stopped. Understood? Good. The reactant that is not completely used up in a reaction is called excess reagent. So how many before? 2 nitrogen here. And how many we use? 1. So how many left? 1. So who is not used? Okay, this is called excess reagent or excess reactant. In this example, nitrogen is the excess reagent because some nitrogen remains unreacted and some means 1. Okay, so we explain this one in detail. Okay students, now let's start with the determining the limiting reagent in a reaction. So how are you going to calculate the limiting reactant? So let's take the example. Copper react with sulfur to form copper 1 sulfide according to the following balanced chemical equation, which is 2 copper Cu plus 1 sulfur S yields 1 mole of Cu2S, which is copper 1 sulfide. What is the limiting reagent when 80 grams of copper react with the 25 grams of sulfur? So, if grams is given, means mass of copper is given, which is 80 grams, and 25 grams of sulfur is given, which is mass of sulfur 25 grams. By using periodic table, you can find out the molar masses. So copper 63.5, sulfur 32.1. Now by using the chemical equation, you can find the mole ratio, which is 1 mole of sulfur needs 2 moles of copper to produce this product. And what you need it? Limiting reagent. Now this is moles. Okay, so you have to compare with the moles, but they give you grams. So simple thing, you have to convert the gram into mole of copper as well as for sulfur. So let's start with the copper first. In the copper, what is given? 80 grams of copper. So 80 grams of copper times conversion factor, remember, okay? So grams of copper is given, so unit of gram of copper going down. What you needed? Moles of copper. So required unit must be on the top, the conversion factor. Okay, so how many moles? For 1 mole we need it. Okay, so this is mole ratio. So 1 moles of copper, how many grams of copper? 63.5 grams of copper from periodic table. So grams of copper cancel grams of copper. After calculation, you get 1.26 moles of copper. Okay, this is conversion method. Boys, remember I told you many times that try to understand this conversion factor or conversion method, because it helps you out many ways. So you can use the formula if you don't go for the conversion factor, which is number of moles is equal to mass of substance divided by molar mass. So what is the mass of substance? 80 grams of copper divided by what is the molar mass? 63.5 gram. After dividing, you can get 1.26 moles of copper. So again, one more time, what is the formula? Number of moles is equal to mass over molar mass. By using this formula, you can get this one as well. Same thing do with the sulfur. You will get 0.779 moles of sulfur. Now boys, you can notice here that 1.26 moles and 0.779 moles both are less than is given. Means it need 2 moles, it give you 1.26 is less. And how many moles you need it? 1 mole and give you 0.779. So it's confusion now. So which one we take as a limiting reagent? So for this, take any one among of them. Suppose I am taking at the moment 1.26 moles of copper as a given unit. So I take the given unit 1.26 moles of copper. So given quantity. Put in the conversion factor again times. Okay, this is the mole ratio from here. Okay, from the chemical equation we get it. So what is the chemical mole ratio from chemical equation? 1 mole sulfur need to react with 2 moles of copper. Okay, from the chemical equation balance, remember this. So moles of copper is given, so given unit must be down. Okay, you can't put like this 2 moles of copper over 1 moles of sulfur. Why? Because given unit mole of copper, and what is given unit must be down, but you need it has to be on the top in the mole ratio. Okay, so mole of copper cancel, mole of copper is a unit wise. What left? 1.26 times 1 divided by 2. After calculation this, the value will be 0.630. What is it? What left? Which unit? Moles of sulfur. So moles of sulfur you put it. So it means if you want to consume whole amount of copper, which is 1.26 moles of copper, you need 0.630 moles of sulfur. So how many moles of sulfur needed? 0.630 to consume all this amount of copper. Okay, remember limiting reactant, what is it? Who used up first? Okay, so suppose this one going to be used up. Okay, 1.26 we finished. And what, how much or how many amount of, how much amount of sulfur we needed? 0.630 moles. Okay, and remember what is given? 25 gram. 25 gram, when we convert, we calculated that 0.779 moles of sulfur. So it means 0.779 moles of sulfur they gave us, and we used only 0.630. It means still some amount of sulfur remaining, and the amount in the reactant remain is called excess reactant. What is it? Excess. So sulfur is excess reactant and copper is limiting reactant, because it used up all completely. I hope you understand this. Okay students, next question is, using the limiting reagent to find the quantity of the product. So amount of product you needed means the amount of product, how to calculate it. So it's giving the same question, but additional is, what is the amount of the product formed. Now you have to calculate first limiting reagent. So which one is a limiting and its amount, and we already calculated in the previous slides that limiting reagent is copper, and how much the amount? 1.26 moles of copper from last slide, remember. But if you don't calculate, you have to calculate it, because without this you can't calculate the amount of product. Okay, so for saving the time, I'm just taking the value only from the last or previous slides. Now you can see here that 1 mole of copper 1 sulfide, how much is supposed to be in the gram? In the gram is 159.1 grams. How you calculate it? 2 times 63.5 plus 1 times 32, because number of atom how many? 2 for copper, and atomic mass 63.5 plus 1 times 32 means 1 atom of sulfur times atomic mass, which is 32.1. When you calculate it and add, you will get 159.1 grams of copper 1 sulfide. This is molar mass. Okay, now compare the mole ratio here. Now 2 moles of copper needs to give the 1 moles of copper 1 sulfide. Okay, so ratio is 1:2. So mole ratio from the balanced chemical equation you get it. So what you need it? The yield. Yield means amount of product. Okay, so how much you formed, how much you produced. That's the term we use, yield. So yield you need it in gram. Okay, remember in gram. So remember 1.26 moles of copper. So 1.26 moles of copper. Okay, conversion factor again, given unit, go for the given unit down, times how many moles of, what is it? Copper 1 sulfide. So moles of copper 1 sulfide, what is the mole ratio? 2:1. Okay, so 1/2. I hope you understand this, what I'm saying, that 1.26 moles of copper times, because of moles of copper is given, so moles of copper going to be down in the mole ratio, and what you needed? Moles of copper 1 sulfide. Now 1 mole of copper 1 sulfide need 2 moles of copper. This is the mole ratio. So moles of copper cancel moles of copper, but we don't need the moles, we need the mass, good, in the gram. So moles of copper 1 sulfide is given here now, because you are converting moles to the gram now. So moles of copper sulfide, write it down. What you need it? Yes, grams of copper 1 sulfide. So Cu2S you're going to put up. Now 1 mole of copper 1 sulfide, how much or how many grams? 159.1 grams by molar mass. Okay, you can get it. So cancel each other, you can get the answer 1.00 times 10 power 2, which is 100. Okay, because 1 to 100 grams of copper 2 sulfide. But why I wrote like this? Remember how many limiting reactant there. Okay, so because of the limiting reactant we must need to do like this. Okay, because if I write 100, so means only 1, but 1.00 means 3 limiting reactant. So how many? 1.26 means 3 limiting reactant is there. Okay, so this is the amount what we needed or what we will get by 1.26 moles of copper. Now this is your question. Read carefully and write on the paper and solve it and let me know on the comments. Thank you so much. Okay, one topic left, which is percent yield. We will continue in the next video.